Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 69 in our incredible new tutorial series where you're unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what we're going to do is we're going to take up where we left off in lesson number 68. Now, what we did in lesson number 68, I showed you how you can run both cores on your Raspberry Pi Pico W. And we did that by creating a thread that ran on the second core while we ran our main program on the primary core. Okay, so we could run basically two programs on the two cores, one a thread and one the main program. Now, it worked very well, but if you played around with it very much, probably you started running into some issues when you tried to terminate the program. And this is what happens when you are doing threading on the Raspberry Pi Pico W. Now, normally, let me come over here. Now, normally, when you are running a program and you come up here and hit the little stop button, it stops the main program. And that is just dandy. But the problem is that if you start a thread and you come up here and then click the stop button, it will stop the main program, but oftentimes it will leave that thread running. And leaving that thread running can cause several problems. First of all, if you come up and try to save a program, you can't save it because the old program is still running. The thread of the old program is still running. The other thing that can happen is if you come in and try to run the program again, you'll get all types of strange error messages talking about the back end this and the back end that. And so what we need to learn how to do today is we need to learn how to terminate our program where we cleanly exit and cleanly terminate the thread as well as the main program. Does that make sense? I hope it does. Okay, now how are we going to do this? We're going to do this basically with the same circuit that we were working on last week in lesson number 68. Just pretend this beautiful red button isn't there because we're not going to use it in today's lesson. It will be part of the next homework assignment. But just pretend this red button isn't there, okay? So what we have is we have a servo connected up. We connected it just like we had it last week. We have the red power wire coming to physical pin 40, which is 5 volts. We have the brown, which is ground, coming to physical pin 38 here, and then the orange wire, which is the control wire, we have coming to GPIO pin 17. Okay, and even though you can see that behind my head, it's basically 3 wires, and it is physical pin 40 for power, it is physical pin 38 for ground, and then it is GPIO pin 17 for control. Then we have 2 LEDs, a red LED and a green LED. The long leg of the red LED comes to GPIO pin 15, and the long leg of the green LED comes to GPIO pin 14, and then the short leg of the red LED goes through a 330 ohm resistor to our ground rail, and then our ground rail is established over here connected to physical pin 3. And then similarly for the green LED, the short leg of the green LED is connected to the ground rail through a 330 ohm resistor. Okay, so that's how the circuit is set up. And then what we're going to do is we're going to go out and get that code that we ended up with in lesson number 68. And so you guys can come over here to the most excellent www.toptechboy.com. And then what I'll need you to do is use this happy little search icon and search on something like MicroPython multi-core programming. And then you should come to this page. And you can come down here, and if you click these two little page icons, you can copy that code, and then you can come back over here to Thonny and you can paste that code into Thonny. Now, just one quick reminder, we did save a servo. We installed a servo library. If you have not done that yet, you will need to come to www.toptechboy.com, and this time you need to use the happy little search icon to search on something like servo library for the Raspberry Pi Pico, something like that. You'll come here. What you'll need to do is you'll need to snag this code, and then you will need to come over here. You'll need to paste it into Thonny, and then you'll need to save it in the lib folder. In your lib folder on your Raspberry Pi Pico W, you'll need to save it as uppercase servo dot lowercase py. So uppercase servo dot lowercase py. Now I'll just show you that here to make sure that it makes sense what I'm saying. We can come over here and view, and we can view files, and you see down here we have the files on our Raspberry Pi Pico W. You should then look in lib, and you should have that uppercase servo.py. Once you've done that, then everything should run just like what you're seeing us do here. Okay, so wow, that was a lot of background. It is time for us to get in here and start coding this thing. Okay, let's start by running this program, and let's just see if this does what we expect. Now, what we expect is the green LED should be blinking fast as the servo is going clockwise, and then as it's going backwards or counterclockwise, the red LED should be blinking. And we did that by operating LEDs in this second core, this other core, and we did that by creating this thread. Okay, let's just run it and make sure that it still works. So I'm going to run that. So backwards the red LED is running, forwards the green, backwards the red, and forwards the green. So that is really working exactly like how we wanted it to. Now, what I want you to see though is watch down here, and when I try to stop the program, okay, what it did was it tried to stop, and then it did a soft reboot, and then it hung up. Okay, so the program seems to be hung, and if I try to run it again, it said could not interrupt the process. So what was the problem? That time, what happened was it killed the main program, but that thread called other thread kept running. So what we're going to have to do is we're going to have to unplug this, and then we're going to plug it in again. And let's try running it again. So this time I need to come back over here and connect to the board again. Right back behind me, I'm connecting to the board again. Now that I'm connected, I'm going to run it. Okay, and the thing is running again. This time I'm going to try to kill it with Control-C, and Control-C doesn't. Okay, and again, I got all these errors here. Different error than before, but it's still, again, hung up on soft reboot. All right. So that could be a problem that you are having. So how are we going to address it? There's going to be a couple of things that I need you to do. And the first is I need you to make sure that you are running on the same version of the MicroPython software that I am. Because if you want to get the same result I do, you need to make sure that we are on the same MicroPython version. And so what you can do is to find out what version you are on, you can come over here and you can down at the command line say import. And what are you going to import? OS. And then what are you going to do? You're going to print the os.uname like that. Okay. You're going to print that like that. Okay, and then we run it. And what was that? I didn't close. Okay. Now I've really got a problem. Let me try it again. Import OS colon, or that's a semicolon, and then print. And I need to print OS dot uname, okay, like that. Open, close, and then close the print. And then this shows you that I am on version 1.22.2. I'm on 1.22.2. If you don't have that, go back and download the new MicroPython, and you do that just like we did it in lesson number 1. Okay, but you go in and you get the new one. And then how do you put it on your Raspberry Pi Pico W? Remember, you hold the white button down, plug it in, and then your Raspberry Pi Pico W will show up as a drive in your Windows folder, and you open that drive, and then you drop the MicroPython, the new MicroPython, over to that drive. Then you unplug your Raspberry Pi Pico W, plug it back in, and you should be ready to go. And if that is confusing, you go back and look at it. We did it in lesson number 1. Okay, so you've got the software. You've got the servo library, you're on the same version of MicroPython that I'm on, and you also need to be on the same version of Thonny. And a lot of us installed Thonny a long time ago, and it was really kind of buggy. It was really kind of buggy with some of the things in the MicroPython and the Raspberry Pi Pico W. So you want to go out and get the same version of Thonny that I have, which is Thonny 4.1.4. Okay, now normally just doing MicroPython and simple things on the Raspberry Pi Pico W, it really didn't matter very much which version of MicroPython, and it really didn't matter very much which version of Thonny you have. But you can see as you start getting to more complex and more sophisticated topics like dual threading, like programming on 2 cores, you really need to make sure that you have this same versions that I have, because those earlier versions were very, very buggy, and these more recent versions are a whole lot less buggy. Okay, and so there's a lot of issues you can have when you're trying to do the threading, and the most important thing is do the update, just like I showed you on Thonny and on the MicroPython. And then the second most important thing is to exit your program cleanly, which is now what we are going to do. So I showed you the example of just running the software like we have it here, how you can run into problems. Okay, and so how are we going to address that? Well, what we want is we want to kind of put a hook in here that instead of this running forever, once we fire this thread up, it runs forever until something nasty happens and it crashes. And so we don't want to do that. We only want to run as long as, let's say, let's create a new variable. Okay, let's create a new variable, and that new variable is going to be called, it might have actually been, this shouldn't have been there already, but when you copied and pasted it, it was there. But what we're going to do is we're going to create a new variable that is called running, and that is going to be true. And so what we want is, we want as long as running is true, we want this thread to keep running. So instead of saying while true, what we want to say is while running. Now what you could say is while running equal true, and then when running isn't equal true, then it will drop out of this. But all you really need to say is while running. Now, for this to know what running is from the main program, what do we have to do? We got to make that a global variable. So we're going to make running a global variable here. Okay, so this running now is going to be the same as this running. And when it gets to this point, and when you fire up the thread, it is going to come in here. Running is already going to be true, and so it is going to run this much of the code. Now, what is going to happen when running is not true? well, then it will drop out of the while loop and it will drop to right here. Well, what we probably need to do right there is print a message which says print. And what we're going to print is thread other core has terminated. And this will allow us to just verify as we go through and get this thing working. It'll allow us to verify that we have, in fact, left that thread. Because after this, there's nothing else to do. And what is it going to do? The thread is going to terminate itself because it's gotten to the end. There's not another line of code for it to run, so it will stop. So once we break out of this while loop, we will get this message and then it will stop. Okay, so now what we need is we need some way to change running, that when we want to stop the program, we want running to what? Become false. Now, there's really not too much hope that we can do it with this little red stop button, but what we can do is we can put some code down in our main program. We can put some code down in our main program where we can put in a keyboard interrupt. And then with that keyboard interrupt, what we can do is we can cleanly exit the program. And the way you do that is, I don't know if we have done try or accept before, but what we're going to do is we're going to say try. And what do I want to try? I want to try all of this code here. And so it now needs to be tabbed over. Each line needs to be tabbed over so it is underneath that try. And so each one of these I'm putting over by one tab. Okay. Like that. All right, and that all looks good. And so what does try do? It tries to do it. It tries to do it. If it can't do it, what does it do? It comes down to accept, and then in accept you say, well, you try, and if you can't do it, come down to accept, and then do the lines of code in the accept. And so if you tried and there was an error, you would jump down to accept. But we're not going to have an error. So we want to jump down not to accept, but we want to jump down to accept key with an uppercase K, keyboard interrupt, like that. So what's it going to do? It's going to go to try, and then it's going to keep looping in the while, and it will loop until it gets a what? A keyboard interrupt, and then it's going to jump down to the accept keyboard interrupt. Does that make sense? It's going to keep looping in that while loop until it sees the keyboard interrupt, and then it will jump down here. Well, what do we want to do here? Well, we want to print. We want to see that it has seen the keyboard interrupt, so we're going to print keyboard interrupt, like that. Okay. And then what do we want to do? We want to make running is equal to false, like that. And then let's see what happens here. Let's see what happens here. Now, what's going to happen? This is going to be up here looping, 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 looping. And then when I hit the keyboard interrupt, I'm going to come down to accept keyboard interrupt. And then running is going to be made false. And because it is a global variable, then this becomes false. So when it gets back up to the top of the loop, it is going to find that running is false, and then it's going to come down here and it's going to print that that thread is terminated. So let's run this thing and see what happens. So I'm going to run it, and it right off the bat doesn't like line 18. And what is that? What's wrong with that? Ah, I put a colon there. Not needed. Let's try it again. Okay, now look at this. So we are going forward in green and backwards with red, clockwise green, counterclockwise red. That looks good. Now, what is the keyboard interrupt? You come over here and Control C is your keyboard interrupt. And look at that. I still got an error code. And what error code did I get? It says it got the keyboard interrupt. That's good. So what did it do? It saw the keyboard interrupt and it got here. And then we're assuming it made running false. But then what happened? Could not read the command configuration, all this strange thing. So somehow, even though this was false, what happened up here is this thing crashed. Okay, this thing crashed. It didn't get down here to this. Now, what probably happened? What probably happened is it makes running false, and then immediately the main thread dies. And as soon as the main thread dies, you know, our main program dies, it's like all of these variables, or at least some of these variables, are probably going to die too. And so this thread doesn't even know what to do. So what do we want? Before we kill the main thread doesn't die. Our main program doesn't die until the last command has been completed. So we want to give it a little time for that false to get up there and for it to get to that line of code. So let's do a time.sleep. Let's just say 0.1. It doesn't need to be very much. And probably I'm going to have to unplug this again and then plug it back in like that. Okay, and now we'll come over here and we will connect to the board again back behind me. That looks good. Now let's run it. Okay, going backwards, going forward, it's running. It's always been running. The question is, can we kill it? Okay, I'm going to come up here, Control C. Boom, look at that. It rebooted. We got the keyboard interrupt. And then we got the thread other core terminated. And so you see we got the boom, boom, boom. We got everything that we wanted. Now the question is, can we run it again without disconnecting it? Boom, look at that. And now we're going to come over here, Control C. Yeah, look at that. Let's try it again. Control C, run it again. Control C, bulletproof. Bulletproof. So what you see in today's lesson is when you're running two cores and you have different threads on the different cores, you've got to think about your timing. And so what did we have to do? We had to put this keyboard interrupt in, and then we had to set running to false, and then we had to give this time to make sure that it went through and got back up here to the top before we let this main thread or this main program die. Does that make sense? I hope it does. Man, we have learned a lot of stuff here today, and this is getting into some pretty deep stuff. So I really need to give you a homework assignment. I need to give you a homework assignment where you can kind of play around with this. So I'm going to give you a threading homework assignment. And let me go ahead and I'll come over here. What I've got is I've added a button. I'm not going to use the LEDs now, but I have a button and I have a servo. And this is what your program needs to do. This is what your program needs to do. And let me okay, this is what your program needs to do. Okay, so I want you to watch this. So I'm going to run the program. And I don't think I ran the right program there. No, I think this is the same program that we had running before. So let me stop that cleanly with a Control C. And wow, that kind of, you lost the focus on that as well. All right, so let me try this program here. So this, I think, is your assignment. So I'm going to run the program. Okay, now nothing is happening, but if I press the button, what I want you to see is that after I press the button, I rotate from 0 to 180 degrees. The servo slowly sweeps from 0 to 180 degrees, and then it stops there. Now, if I press this again, it goes from 180 degrees back to 0. Now, if I press the button in the middle, it ignores it, right? It ignores it if I press it in the middle because it completes its operation, the first command that it got, and it stops. Okay, and then I press it again and it goes. So, okay, I've got one button and I've got one servo. And you need to do this using both cores, and you need to do this using threads, your thread. And then what you also need to do is you need to make sure that the program doesn't crash when you do a Control-C. So what I'm going to do is I'm going to Control-C. I killed the program. You can see the program is killed because it doesn't work anymore. Now I'm going to run it, and then I come over here and you see it is working. I can Control-C, and I'll kill it here in a minute. You saw it, right? So Control-C kills it, and then it terminates that thread properly. Okay, it terminates the thread properly, and then it toggles based on the pressing of the red button. That is your homework assignment. And you see, what am I trying to get you to think of? Two things. How do you do threading? How do you use both cores? And then finally, how do you exit that program cleanly, where you can run it again and again and again without having that problem of the dangling thread running. Okay, guys, I hope you're having as much fun taking these classes as I am making them. As always, I want to give a shout out to you guys who are helping me out over at Patreon. You're the ones that are keeping me in this game, and I really appreciate it. You can also help me by giving me a thumbs up on the video and leaving a comment down below. If you haven't already, subscribe to the channel, and when you do, ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering. And fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.